NTU-MIC was established in 2011 under the auspices of the Taiwan Ministry of Education. The center is a platform that combines imaging resources of NTU and excellent clinical experience of NTU Hospital to facilitate interdisciplinary research of molecular imaging. We are one of the 7 university-level centers at NTU, and our mission is to attain academic excellence of NTU and to have a profound impact on society.
Hello, I'm Isaac Tsing. I'm Chief Director of NTU-MIC. To fulfill the mission of NTU-MIC, we have the following goals. First, to perform novel research projects by integrating multidisciplinary resources at NTU. Second, to create leading-edge researchers by cultivating young scientists and engineers in frontiers of molecular and biomedical imaging. Third, to realize personalized medicine by conducting translational research from bench to bedside. And fourth, to facilitate commercialization of innovative medical devices by forming a liaison with industrial partners.
Currently, we have 47 MIC members. They come from 7 colleges at NTU. We have 4 divisions to manage clinical translation, academic affairs, administrative affairs, and international industrial affairs. Moreover, we have 9 core labs. These labs are the real workhouse of the MIC research. We report our progress every year to the advisory committee. They review and give comments on our performance. NTU-MIC members are highly motivated to solve unmet clinical needs. This underlines the strength of the NTU-MIC. The strength is the closeness among scientists, engineers, and clinicians in translating innovative diagnostic or therapeutic technologies from bench to bedside. In the past 4 years, the NTU-MIC has developed many innovative imaging techniques, including optical imaging, ultrasound, positron emission tomography, and magnetic resonance imaging, and applied them to clinical diagnosis of cancer, cardiovascular, and neuropsychiatric diseases. Some of the techniques have entered the clinical trials for the application of FDA or TFDA approval. Besides this, we have developed over 50 international cooperation activities within 3 years and continue to actively organize large-scale international seminars to promote various national key research institutes to cooperate and communicate. The quantitative dual-spectrum IR, QDS-IR, is a hazardless and non-invasive system of early detection and chemotherapy response monitoring. For early detection, the sign was about 6 months earlier than the sonogram. For chemotherapy response monitoring, 90% of these subjects have the same tendency between the QX max values and SUV max of FDG PET. The goal of the Digital Library Core is to establish a data-sharing platform that helps users to archive, transfer, and compute their image data. The mission is to facilitate the discovery and availability of biomedical imaging markers.
I'm Professor Weifang Su. Welcome to our Molecular Engineering Core Lab. The objective of our lab is to develop scaffold material for tissue engineering using molecular design, synthesis, and processing. Our focus area is optical nerve regeneration and central nerve regeneration.
Cryo-electron microscopy, cryo-EM, provides architecture of these molecular machines in the range of 10 to 100 nanometers and extends the capabilities of structural biology. We aim to understand the molecular structure of these macromolecules, which is not only essential for the comprehension of their function and mechanism, but can also provide clues for the developing therapeutics related to health and disease. We have worked on many proteins using cryo-EM and image processing technique. The earthworm hemoglobins are highly cooperative oxygen-carrying proteins. We found that the oxygenation causes a radial expansion of the complex, which initiates from the interaction between the F helix and heme group. This ultrasound core lab aims at providing ultrasound-related molecular imaging services. The specific items include ultrasound and photoacoustic molecular imaging services, molecular probe designs, in vitro and in vivo experiments. Using our high-frequency ultrasound system with a 20 MHz push probe and a 40 MHz imaging probe, the liver stiffness was measured serially in C57 BL6 male mice for 4 weeks by shear wave elasticity. The goals of the optical imaging core are to improve early diagnosis and risk assessment of diseases, as well as to aid research in preventative and regenerative medicine. We aim to develop innovative optical molecular imaging technologies and establish preclinical and clinical study platforms based on the advantages of optical technologies. To date, we have developed 3 major optical microscopic systems, including the in vivo harmonic generation microscope system, the 2-photon photoacoustic microscopic system, and the super-resolution multiphoton microscope system. These facilities and techniques allow us to investigate the fundamental science of molecular biology for clinical applications in medicine. We combine expertise in fundamental science, engineering, and clinical research, with emphases on important health issues including cancer, as well as neuro, metabolic, and cardiovascular diseases.
The purpose of the molecular imaging is try to detect diseases in the early stage and make efficient therapy for the patient. In our lab, we developed the next generation MRI with extra fast imaging sequences and extra high resolution so that we can disease dementia, cancer in the early stages. For the best effective therapy, we also develop quantitative MRI imaging tool such as QSM so that people can come back and forth and have the longitudinal study, for example, in dementia and cancer studies. I think the center of the purpose is to develop an excellent center in Taiwan with the advanced technology and the advanced instrumentation we have here. We think in the next 4 to 5 years, we could really achieve the best MR molecular imaging site in the world.
I'm the director of the PET core lab, Kai Yuan. Our lab provides PET service, PET scan service, which is one of the most important part of molecular imaging. And actually, PET scan is used in the clinically for neurology, oncology, and cardiology study. So we extend the service to molecular imaging, that's PET scan, for the animal research of the human disease. So we use mice, rats, and also other animals for PET study that will help us solve the problem of human disease.
Hi, I'm Jack. The mission of Molecular Product Development Core is to discover and develop novel molecular imaging agents, especially for positron emission tomography, as tools for basic research, clinical diagnosis, and drug discovery.
As a physician scientist, I witness outstanding research capabilities in the NTU campus, as well as world-class medical training and patient care in the NTU hospital. I also foresee the unprecedented challenge of an aging society that will impose tremendous medical and financial burdens in the generation to come. These facts help shape the unique role of the NTU MIC. This is a hub of innovative research aiming to provide solutions to the clinical challenges related to age-related diseases. Based on the strong capabilities in biomedical research and imaging techniques of NTU MIC members, I believe that the NTU-MIC will be known by the world as the molecular imaging center that safeguards people from major age-related diseases.